Hi, I'm here with Philippe Tillet, the creator of Triton. Hi, Philippe. Welcome.
Hi, nice to meet you.
So you were thinking about Beyond CUDA before the Beyond CUDA event. You had the vision of Triton, the Triton language, and the great equalizer of programming GPUs. So tell us more about your vision and how you've brought Triton to life.
Yeah, so I guess initially that was pretty selfish. I just wanted to make my life easier as a kernel developer because I was sort of in this situation where I was like handwriting low-level GPU code, and every time like something new came out, like an algorithm or a GPU, I had to rewrite the whole thing. That became like pretty frustrating. So Triton was just born out of desire to like get myself out of this pickle. So yeah, that was like that started like that, and then that sort of naturally turned into like something a little bit bigger. But I didn't really plan for it.
Nice, but it's good. It's good because now there are like Mark from GPU Mode had. He just mentioned the first thing that someone comes to start programming in is Triton, right? They don't, if you need Cutlass assembly, that's like a niche. But the first entry to GPU programming is Triton, and I think that's like shows to talks to the vision you had of like building an easy to use DSL for GPU programming. What do you think is next for Triton? Like, where do you want to take Triton, the language, and the vision for the next 2-3 years for Triton?
Yeah, so we never really planned that far ahead. I think in general, like my goal has always been to like try to keep doing the same thing well as new hardware comes out and new algorithms come out. I think it's pretty hard to be like a robust compiler that like works for like every possible program that everyone can think of. But it's really what we're trying to do here. It's like if people have like new algorithms ideas or like anything they can come up with, they should sort of be able to express it in Triton. And it's not always going to be the fastest, but at least it's going to be like much faster than like what you would do if you like wrote it in PyTorch. And then like for some kind of workloads that are like very common, like matrix replications or attention, we can always like try to optimize those and make sure that these do well. So I think we sort of hope to make sure that this keeps being the case.
Nice.
As long as like new hardware comes out.
Yeah. Yeah, good. And can you talk a little bit about like AMD support and from an AMD standpoint, we're 100% in, committed to Triton. Would love to get your color on, Triton support for AMD hardware.
Yeah, so it's a project that started 2 years ago or so, and it was a little bit slow to ramp up, but really started getting steam a year ago. We upstreamed the AMD backend. We've been working on it ever since. I think there's like a great lead for the AMD backend. It's going pretty well. I think what has really helped there is we've built a lot of shared infrastructure between the AMD backend and the NVIDIA backend. And so most of the improvements that we make end up like being generic and working on both platforms pretty well. And also this makes sure that we are robust. So we don't have a ton of things that are like too AMD specific. So usually like if you're a Triton program, it should work on like both platforms fairly well.
Yeah, and I think the Mark from GPU Mode has like the kernel bot leaderboard that people can program in Triton and test on both AMD and NVIDIA. That's great to hear. And I've personally seen customers get really excited about like there are some variations of they need int4 this plus FP8, some corner case of something that they may have done on NVIDIA and it just works with Triton on AMD. So we've been able to deploy a few customers that way. Speaks to the breadth of where Triton is going today. And given that you had the itch to scratch and build Triton, do you have an itch today that you have to scratch? What do you want to build, and doesn't have to be Triton now, right? Like and nothing like just at a meta level. Is there anything like that you want to spend time on and focus on?
Yeah, well, first of all, I feel like Triton is still not completely solved. I think there's like important problems like meta programming that we haven't like addressed super well yet. But I think there's like probably a missing layer between, I think, Triton and PyTorch, where there's things to do, new programming models to come up with. It's not something I'm working on actively, but I think it sort of needs to be solved. I think there's space for something there.
Nice. Good. Thank you for joining us, and good job with Triton, and continue the great work.
My pleasure.